Okay, this is a demonstration of part one of my coursework. Um, Here you can see the source code. This is where I just connect to the Twitter API. Simple searches are done probably down here. So yeah, you can find a user based off. So that's the returned account we want to find, and we want one tweet from them. So that's how we would use the Twitter API. Simply API.user timeline. We can search for specific. I search specific words as well, but that's how we connect there. As far as cosine similarity goes, I've implemented my own calculation of the angle between the two vectors, and I've implemented my own frequency where I read the whole CSV, create a bag of words, which is just the frequency of each word in my CSV, and then so when I want to adjust, I can just divide by the amount, which will give me better weightings. You can also see in my CSV here, I have implemented randomness. So it will choose one of three responses. Sometimes I want the same response each time, so it doesn't matter, but it's just easier if I have them all on the same. You can see all these. Um, if the CSV decides that I'm doing a Twitter search, it will just reply with a tweet search. And then you can see in here, when we get a tweet search, I then take the message from the user and check that against my Twitter check. If it can't find someone in here, it will search for 5 users and then print that list of users off. It will also add the users to this document, prompt you again for the name of the user, and then do another CSV, another cosine similarity against this document here, and so that should find a user. So I shall give you a demonstration of that now. So we saw Trump was in that. Let me just close it so that we can open a second, see that they are added. So Trump was in that CSV. So if I say, what did Trump tweet? We can find the most recent tweet by Trump. Sometimes emojis and links don't always work. That is, and then also say something like with apostrophes, because it is UTF-8 encoding, there are some issues that I need to do with cleaning and everything like that. But for the most part, you can just see what Trump's most recent tweet was. Now, we saw Taylor Swift was not in there. So if I typed in, what did Taylor Swift tweet? She couldn't find that user, but it gives you a list of ones to go against. And since we had Taylor Swift, and her most recent tweet was just a link. So you can see it's come out very well. There's 2 different links, probably a retweet, retweet link, and then a link in the actual message. But you can see now if I open my Twitter check, all of those are added to my document of accounts that I know of, and you can see their unique identifiers go on the side. So the Twitter bot becomes increasingly knowledgeable as it works on. The what should we talk about next? Next part of the code, we'll look at our XML. So you can see here we've got a little bit of memory implemented. So when we specify the name is then used in later parts. If it's also adjusted so that if the name's not given, all the sentences still make sense, but there's just a little personalized and more intelligent feel to the bot with a different name. We can also see in the XML we're differentiating between two different things that the user's asking for. So we have ones are when we are looking for tweets with just for a word or a category to search for, and twos are when we're specifying it's a user's tweet that we want to find. So this is the Twitter API stuff here. This is the XML. At the top here, we can see we've implemented some randomness just to give the AI, the bot, a bit more of a personalized feel, and can lead to different conversation arcs overwards. You can see that most of these lead on to questions later. So you could get, what is your name? Then you reply with your name. I am, my name is, and it should be able to set the name. So I'll show that here. If we run, we could do hello, hello, how are you? Or if we do a hello again, hello, nice to meet you. Or hello again, what is your name? Then you reply with, my name is Tom. Tom, that is a nice name. And then ask it, what is my name? Or your name is Tom. And when I say bye, you can see, bye, nice talking to you, Tom. And then you could also see that it would be, without Tom, it would be nice, Bye, nice talking to you, which makes complete sense on its own as well. You can also, I'll show you a quick demonstration of the randomness in the CSV. Literally how it works in the source code is, where is CSV? Where is CSV? Oh no, it's in the when we actually choose, isn't it? So you can see. When I do cosine similarity, I open my CSV and then I go through each row in the CSV, comparing its phrase to my initial message through my calculate cosine function, and then it just saves the highest response as we go through the rows through that, and then we have a random choice. We either choose the second column, third column, or fourth column, which will have usually different responses. Some of them have the same. Obviously, if we're looking for a tweet search, they will have tweet search, but that's how the randomness works with CSV. And then obviously, randomness in XML is shown here via a list. Let's just show you the CSV randomness. So, did you know that Biden won the election? And the bot replies with, how cool. And if I put, did you know that Biden won the election again? He says that's interesting. Equally, because it's CSV, it'll be able to take in all different did you know. So did you know I am the creator? That is interesting. So yeah, we've got randomness implemented, we've got memory implemented. There's two different functions as far as tweeting goes. So find me tweets containing happy. Oh, that did not work. Let me find out. So here we go. It's search for, and then politics, shall we say. My search for politics found the following most recent tweet. So you can see we have not implemented cosine similarity with searching for tweets. It's just in the, as far as the XML goes, but you can see we find a politics tweet there. You can see all the different commands that it recognized here. Showing you searching for a user, showing you searching for a specific category. Is there anything else I would like to show off? I don't think so. We can walk through the source code quickly. So this bit's for connection to the Twitter API. This bit's all part of my frequency, getting my bag of words, and then checking if the word's in my bag of words, and if it is, dividing. So if the turns up twice in our vector, but then we've got it 4 times in total over the whole CSV, it'll divide the 2 by 4 here. Cleaning the string, just making we didn't remove stop words because that did end up hampering with the CSV and sometimes removing just all words. But we are making sure that we're getting rid of certain that we're getting rid of, trying to get rid of emojis, trying to get rid of links. You see, it breaks it up. Sometimes it recognizes some parts of the link as words, but it's much cleaner than it could be. We'll say that for sure, because it does come in a bit of a weird format from Twitter itself. Here, this is just simply where we clean it and implement the frequency if it's not the original messages, because we don't want to weight any messages in our any word in our original message. We only want to weight what's in the CSV. This one's for finding a better response. This one's for finding a predefined user. And then here we have AIML at the top. You can see if we get a 1 response, we're searching for a user. If we get a 1 response, searching for a category, which is simply here. And if we get a 2 response, then we're searching for a user. And you can see here is what happens if we don't find a user. If it doesn't find a user, if it does find a user, then it just outputs it at the bottom here. But this is if it's empty. Then finally here is the CSV, and if CSV fails, then we just have a default response at the bottom. So yeah, that is my presentation.